In the previous video, we started our fork design by inserting our bicycle geometry file into our fork file, which became our first feature in the feature tree. In doing so, we brought over into our fork file the planes and sketches that were contained within the bike geometry file. Most of the planes and sketches in this file were not necessary for the creation of the fork, so we went ahead and hid these so we could focus on the important details that we cared about, which was the fork dropout layout and the important tube diameters. We finished that video by making a new plane that passes through the steering axis and a plane that passes through the edge where the crown of the fork meets the underside of the head tube. I showed these steps slightly out of order with respect to the sample file that you've been supplied with. The next several steps are going to be some of the most important ones for making a successful fork. This is going to be the creation of the layout sketches on the front view and on our right-hand tilted plane. If you take care at this stage of the process, there's a much greater chance you'll be able to successfully build your fork without a lot of problems. So the question is, what exactly do we need to draw in these layout sketches? To understand that, let's take a look at a completed fork. The main part of the fork is the blade, which sweeps down from the crown down to the fork end. The fork ends are flat plates, which have the dropouts cut into them. Down in this area, the blades have to taper down to meet the flat plates of the fork ends. The blades are created by sweeping a profile, such as this oval shape that you see highlighted here, all the way from the crown down to the fork ends, and then some excess is trimmed off before the fork ends are glued on. This sweep is a sweep with a path and 3 guide curves. So let me roll this back so we can see just what the sweep by itself looks like without all the other additional parts. So here's our sweep, here's our profile. And we notice 1, 2, 3, 4 lines running through this particular sweep. Those 4 lines are where our paths and guide curves are guiding this profile down to the fork end. For this video, I'm assuming that the cross section of the fork is going to be a shape that has 4 apexes, such as this oval or this sort of curvy diamond shape, again with 4 apexes, or even these 2 curves can be thought of as having 4 apexes or corner points. Even a teardrop shape can be thought of in that way. If you're going to do a cross section like this boxy shape or this trapezoidal shape, which also have 4 apexes, but you see that they are arranged differently. Instead of on axes, they're out in the outer corners. So here we can see our oval shape. We can sort of imagine those 4 corners or apexes. Now if the front of our bike is here, what I'm going to do is call this edge or guide curve the leading edge. This edge is the trailing edge. This is our outside edge, and this will be our inside edge or guide curve. I use the terms edge and guide curve somewhat interchangeably in this case. So looking at our oval of our blade in wireframe mode, outside edge, inside, leading, trailing. Now you'll notice that when I look at the blade in wireframe mode, I look at it from the front plane view, the outside and inside edges perfectly align with each other from this view. And if I look from the viewpoint of the tilted plane that passes through the steering axis, I see that the leading edge and the trailing edge appear to be perfectly in alignment with each other as well. So now going back to our fork file that we're working on our front plane layout, we need to draw a depiction of the leading edge, the trailing edge, and also this edge which represents both the inside and the outside edges superimposed on top of each other. we only have to draw this curve once because it will represent both the inside and the outside curve at the same time. On the tilted plane that passes through the steering axis, what we have to draw is the outside, the inside, and this curve here, which represents in this case both the leading and the trailing edge, superimposed upon each other. Once again, we only have to draw them once because they're going to represent both curves at the same time. When we have these sketches drawn, we'll then be able to copy the appropriate curves from them and make the appropriate projected curves that will eventually be our guides for our sweep. There's a few other things we want to add to these sketches as well. Up here at the top, we'll add a crude representation for what the crown itself looks like. And down here at the bottom, at the fork ends, we need to draw what the plate of the fork end looks like, along with this tapering section that blends it into the blade, and do the same sort of thing on the front plane, showing the fork end with the dropout slot added into it. In order to avoid making this particular video too long, I think we'll focus just on drawing the sketch on the front layout plane, and then the following video will focus on the sketch on the tilted plane through the steering axis. For this video, I'm going to be reproducing the example 1 fork, which includes just a gentle swept fork with a blended in fork end. From the front, we see that this fork starts out just wide enough to clear the tire, then has to go wider as it gets down to the fork ends to accommodate the width of the axle. Now, I want to stress that when you're doing your project, what you're going to be doing is not simply duplicating what I've done in this tutorial file, but actually creating a fork with your own shape. It could be something sort of like this, but perhaps with a different cross-section and a slightly different shape, a slightly different end, which might yield a result something like this, for example. It has more of a bent shape to the blade, a more flared out fork end, and a different style of crown. This fork doesn't look too much different from the example that I'm going to be working on in the tutorial. If we take a look at the cross-section, we see that the cross-section of the blade is a very extreme flat blade-like shape as opposed to a nice gentle oval. So there are quite a few different variations you can do on this theme. So finally, let's take a look at this front layout sketch in detail. At the moment, the only sketches I have visible from my by geometry file are the dropout layout sketch and the important tube diameter sketch. Copied from the important tube diameter sketch is I've copied the steering tube, this line that represents the top of the crown, and I've added in these lines to remind me that the diameter of the crown needs to match the diameter of the head tube. I also temporarily turned on my frame layout sketch just so that I could copy the circle that represents the outside of the tire. By knowing where the top of the tire is, I can make sure that the top area of the blade will not be rubbing against the tire. So I copied into this sketch the center line that passes through the center of the steering tube, and I drew a line perpendicular to that. Then what I did was drew a placeholder for the cross section of the blade. In our case, we're actually making an oval shape that we're going to be controlling at 4 corners, but I don't want to draw the actual oval shape in this sketch because the true oval shape that will be swept needs to be drawn after the guide curves are completed and have Pierce relations to it. So this diamond shape here is just a placeholder to remind me of where the 4 corners of the oval are going to go. So I've made the height of the diamond shape about 25 millimeters, which is reasonably typical, and the length, which effectively is going to be the width of my blade in this direction, 55 millimeters, which again is somewhat typical. Your numbers certainly do not have to exactly match these, but this dimension on the blade should definitely be larger than the diameter of the crown. So now zooming out, you see what I've drawn are the curves that represent the trailing edge, the inner and outer edge, and the leading edge, and they sweep all the way down to the fork end. These can be arcs or splines or straight edges or whatever is necessary to achieve the shape that you want for your blade. I'm going to go up at the top here though, and there is one important consideration. This portion of the inner and outer guide should go straight through this area before it starts curving in this area. By going straight, this is a straight line from this point to this point, it makes sure that the outer guide and the inner guide both are in the same position when they pass by this point. That will be important later on when we're trying to make accurate projected sketches. So just trust me on this one. Make this portion straight before you do any curving on this inner and outer guide. Going back down to the fork end, I can see from my inserted geometry file a representation of the fork end and the dropout. I'm going to make my fork end just a little bit smaller in diameter than the layout sketch, but what's important is that this is on center with the layout from the geometry file. This represents the center of our axle and our wheel and our dropout. I've made my blades come down tangent to this circle and this inner outer guide going right to the center. Zooming out again for a moment, we see that this line here is an extension of the steering axis line. I've drawn lines perpendicular to that line. This one passes right through the center of the dropout. This one connects to a line that represents where we are going to trim off the blade so that it can blend into the fork dropout area. And this one goes tangent to the circle of the fork end. When we draw our layout sketch on the tilted plane, which also passes through this axis, we'll see the importance of putting these lines into this sketch. Now, something that I did not do, but you might want to consider, is also copying the lines of the dropout slot into this layout as well. That way you can later on hide this sketch and never really have to re-show it again. Everything you need to know will be contained in this one layout. Up at the very top of the sketch, you also want to copy the line that represents the very top of the steering tube. Once you have all that information into the sketch, you can probably get away with hiding this layout that came from the inserted frame geometry as well, and never have to reopen that again during the course of the fork creation. Everything you need to know will be built into this layout sketch. So that completes this video. In the next video, we will worry about the next layout sketch, which will go on the tilted plane that passes through the steering axis.